月的 Taipei AMPA 系列展呢，以虚实整合的方式联合展出了。在我们 AMPA 的 Digital Go 当中，不只是我们线上的展览，也是囊括了包含像是多元化的文字，甚至是我们影音内容的全新商业模式。虚实整合的展览其实造福非常多人，包含我们参展与会的朋友，我们可以体验一如既往的观展洽谈，也可以替没有办法现身参与的所有的买主来实现不受时空限制的观展模式。成功的可以找寻到呢异业结盟合作伙伴，甚至是激荡出更多的合作商机。这一次的实体展览呢，将会是在4月的20号到23号，为期3天的时间，在南港展览馆1馆盛大展出，同时也规划了包含国际论坛，还有我们的达人讲堂，还有达人主题导览等等丰富精彩的研讨活动。而今天的圆桌论坛的主题，正是我们展览的重点。我们智慧联网的车下一步到底是什么呢？ What's next for intelligent connected vehicles？ 今年的圆桌论坛，我们将讨论最新一波的全球晶片荒。举例来说，对于我们汽车产业还有相关产业，想必是有了相当大的影响。那话题呢，也将会是聚焦在我们智慧联网车辆面对的挑战与机会，未来的技术发展，还有趋势及创新方向。让我们欢迎今天的论坛主持人 E-Times 一点Taiwan 编辑 Susan， 掌声有请 Susan。
Thank you, Doreen. All right, let's invite our panel speakers to join us on the stage. Ladies and gentlemen, and all of you who are watching online now, thank you so much for joining us. This is Susan. Welcome to our 2022 IOV Roundtable. Today we're going to have 1 hour panel discussion on what's next for intelligent connected vehicles. We have invited 5 experts to join us together, including all the panel speakers on the stage and also our moderator from the UK. They're going to share their insights about this topic shortly. Before this, let me introduce them one by one. On the stage right now, from left, we have Gabriel Chou from Macronix. Simon Teng from Jeff Yan from NVIDIA. And Alex Zheng from TTIA, Taiwan Telematics Industry Association. And ladies and gentlemen, our moderator, Nitin Daha. It's a pity that he couldn't join us here on site due to the pandemic. He is actually moderating in this section online from UK. Can you show our moderator? Okay. Okay, let me introduce him first. He is the correspondent of EE Times and also editor-in-chief of Embedded.com.
Hello. Thanks, Susan.
Okay. Hi, Nitin. Please, ladies and gentlemen, please say welcome our moderator, Nitin Daha.
Thank you, Susan.
Hi, Nitin.
Good to be here again for the 2022 IOV Roundtable. As Susan said, I'm a correspondent with EE Times and editor-in-chief of Embedded.com. On this panel, we're going to look at what's next for intelligent connected vehicles.
Okay.
Before we get to our panelists to introduce themselves, just a little bit of an introduction. So obviously, the big thing on everybody's minds is, the automotive industry feeling the effects of the ongoing global semiconductor shortage. As a result, the chips are down, especially for the future of connected cars, with the semiconductor crisis showing no signs of abating. But despite that, in recent years, we certainly saw a trend where chips and semiconductor solutions have enabled vehicles to be connected with various devices and services, making mobility safer, convenient, and faster. However, this trend is now facing challenges due to various factors, including the shortages, but other ongoing developments such as increasing cybersecurity threats. So what we're going to do in this panel, while our panelists acknowledge that there are these ongoing challenges and the impact from the chip crisis, we'll focus, like last year, on the challenges and opportunities facing connected vehicles, explore some of the trends and innovations. So on the panel today, we have a panelist from Macronix, ARM, NVIDIA, and the Taiwan Telematics Industry Association, or TTIA. I'm going to ask each of them to introduce themselves and who you are, your role, and outline specific areas of your work in the connected vehicles ecosystem. So let's go. Okay, can I see the stage, please?
I think we can start from.
Okay, let's go to Gabriel Chou first of Macronix.
Okay, thank you, Nitin.
Gabriel, over to you.
Okay.
Tell us a little bit about yourself.
All right, thank you. So, hello everyone. My name is Gabriel Chou from Macronix. I'm in charge of automotive solutions from the memory perspective. Okay, so that's all. Thank you.
Thank you, Gabriel. Next we go to Simon Teng.
Hello everyone. My name is Simon Teng. I work for ARM, in charge of the automotive business in APAC region. I think everybody knows that ARM is providing the IP for semiconductor industry. My responsibility is trying to convert and promote the ARM specific design for the automotive, especially in the process architecture. But I think recent years, when we engage with the OEM and the tier one, more and more demand asks ARM to involve in the software architecture shift. So I think currently we are not only just providing IP, but also trying to work with the OEM and the tier one or the industrial partner, trying to see if we can contribute ARM's effort to build the next generation's platform, including the software and the hardware. Thank you.
Thank you. Next to it, we're going to go to Jeff Yen of NVIDIA. Jeff.
Hi, my name is Jeff Yen. I manage technical marketing for the APAC region at NVIDIA. I don't have I don't just cover the auto industry, but however, I do cover all of our products in NVIDIA, products and technologies. So,
thank you, Jeff.
Yeah.
Thank you, Jeff. And finally, Alex Cheng of TTIA.
Hi, my name is Alex Chen. I am General Secretary General of TTIA, Taiwan Telematics Industry Association. We have about more than 200 member companies or organizations, which include their government agency, telcos, or even system integrators, or hardware, software, or even solution providers. Team up together, we provide solutions for connected vehicles market. That's basically what we are. Thank you.
Thank you. So let's start with the first question then. I read recently that connected vehicles are the next big thing after electric vehicles. Can you, each of us, give a perspective on where we are in the evolution of connected vehicles, and specifically highlighting any developments in standards, technology drivers, wireless services, and use cases? Who'd like to start? Maybe should we start with Simon Teng from ARM?
Okay. Well, I think this is a very, very broad question, right? Connected car. So I think from my understanding, the infrastructure, actually like 5G, like V2X, there's a lot of standard already there and also been there for many years. So I think for the current situation in the connected vehicle, is trying to deploy as much as possible to make this kind of a standard device will be available in the vehicle. But I think that is the current situation, just building the foundation of the infrastructure. But beyond this, what the OEM going to do with this kind of connected vehicle will be the next kind of a big things for the OEM to think about that. So as I mentioned during my presentation, I think the service platform and also the more application will be developed in the cloud. So how the OEM and the car OEM can, based on the existing current architecture, to migrate into the next generation to leverage the benefit of the connected vehicle platform. I think that will be probably the next big thing from the investment from the OEM. And this kind of a transformation will need a lot of a partner or the industrial companies joint effort, including even the open source community or a lot of a kind of a commercial company entity to invest a huge effort to make this kind of work. I think there's also providing a lot of opportunity for everyone, including the Taiwanese industry. Thank you.
Okay. Who'd like to offer? Maybe we can go to Jeff. Jeff, do you want to sort of look at it?
Yeah, sure. When we look at a connected car, I think connected vehicles these days, there's so many different definitions to it. Like we were discussing earlier, some people think in terms of autonomous driving or whatnot, or even OTA updates. But even more direct that you're seeing today is just connected cockpits, right? The experience within the cockpit itself, the driver experience, and then we see that there's so much to build on that. Just even the UI itself, the user experience itself has changed in, say, the past 5 years, and we see with connectivity, you're going to see even more in that experience change as well. So we see it as a multifaceted area. I guess just like Simon said, right? It's a really broad question. So everything from the driving to even the cloud-based stuff and also these user experience, all of this combined, you're going to see that as all part of the connected vehicle.
Yeah, obviously. And so Gabriel, maybe what's the perspective there in terms of where we are and where things are going and any particular use cases?
Yes, so I would like to address from the memory perspective. So as Simon and Jeff just mentioned, all those fancy standards, and what we observed is that in the connected cars, there's guaranteed to be more MCUs, sensors, and everything else in the car. So attached with it actually is what's needed is a source code or execution code to be stored. Okay, so memory in this place, we see that the higher density, higher reliability, and open standard. Okay, so that's adaptive to all the evolutions of the standards is viable. And also we see that, for example, upcoming in Macronix, we're developing, for example, 3D NOR flash, utilizing the 3D architecture to develop higher density memory solution with a very good speed and reliability and so forth. So this is actually, we're trying to attach to the future trends of the memory needs.
Okay.
Thank you.
And anything you would like to offer, Alex? I think
Yes.
it'd be very good to get some use cases as well.
Yes. As you know, Taiwan don't have a car maker or the brandings, but you might be surprised. According to KPMG 2020 Autonomous Vehicle Readiness Index, Taiwan was ranked 13th place. Okay, that means we have a very good achievement on the autonomous. Actually, we're talking about connected car. The technology on the car industry, people, most of you might know, is a case. Connected is the basic for autonomous, for electronics, for share. So later on, we might talking more about this progress. So I just want to share with you, we are very honorable to be able to achieve this kind of result. Okay.
Sorry. In terms of, are there any? I mean, I know we sort of gave a quick introduction there, but does anybody feel there's a really strong use case that they've seen in the last 12 months that shows a specific aspect of connected vehicles in play, maybe as commercially or in trials? Does anybody want to pick up on something that we can see that's been happening since we were last here? No?
Okay. I think in the last 12 months, there is quite significant one. We know that in Germany, there's a government approvals level 3's commercial vehicle on the road, especially from the Mercedes-Benz, right? I think that is also a kind of a very, very good use case to leverage the connected car and cross the boundary and become the commercial and running on the road. So the foundation of that kind of a level 3 autonomous vehicle is the connected. So I think that is also quite significant in the automotive industry.
I agree. I think we were discussing this earlier, and part of it is, for Gabriel and I, we've been doing this talk for this panel multiple years, right? And even from, say, 3-4 years ago, we were talking about how policy influences how much you can do, or when we talk about developments, there's constant developments. Just that when you're talking about connectivity or how reliable it is, or even the rolling out of 5G, all this kind of pulls in policy. And then if the policy doesn't change, every company is just waiting to do more, right? But this is also region dependent, and it depends everywhere. It's all different.
Yeah, I think from the recent 12 months, I would say that the 5G will play a critical role in terms of the connectivity in the car. So if we compare, for example, the reliability and the bandwidth, I think 5G will play a very crucial role in the coming IoV and everything else of connectivity in cars.
Yeah, that's an interesting sort of segue to the next question, really. I mean, a lot of people do talk about 5G being the solution for addressing vehicle connectivity, but there's different layers of connectivity on that. So it's not just about 5G. What are the ongoing challenges around connectivity to enable connected vehicles, both in terms of infrastructure as well as enabling that vehicle to anything connectivity? Maybe we can start with yes, Alex.
I'd like to put a note. Okay, most of people thinking about connectivity go to 5G or even the autonomous. I think the other way around for share or for service might have more good news. Like I can give an example, like a Google. They just go IPO in Nasdaq. Okay, and they are connected, but it is not V2V or V2X or autonomous. They are more focused on efficiency, share, or green or green power. So I just want to add a small comment. Say not just autonomous or electrical. Okay, thank you.
Yeah, but I agree with Alex here, where most people, when they think connected vehicles and 5G, they think autonomous vehicles, right? But that's not necessarily the case today, right? You're looking at we're not sure how that will fit together in the near future, right? But at least when you're looking at monitoring or OTA updates or even updating your own mapping for advanced ADAS, right? All this stuff fits into the connectivity route. It doesn't have to be necessarily jumping all the way to, say, vehicle to vehicle or V2X or whatever, right? As of today, when you're looking at connectivity, there's such a it's a wide range of things that are connected from your vehicle.
Okay. anybody else would like to offer anything on infrastructure or connectivity or?
So Nitin, you talk about the challenges. I think one of the challenge is, security, particularly, for example, like you mentioned earlier, the cybersecurity. As the evolution of, for example, 5G and everything else, in terms of standards, is very fast-paced. And while we do, for example, ISO 26262, and also ISO 21434, all these standards, how can semiconductor development catch up with all the new security and safety standards? And how do we enable those security inside the car? So take, for example, 20 years ago, maybe there are like 30, 40 MCUs in a car. Nowadays, more than 100 or 200, 300 MCUs in a car is like a common practice. Okay, so how do we ensure that all the safety all connected together? That's, I think, one of the major challenges.
Okay, for the 5G, I think for the connectivity as infrastructure, I think the next one will be creating the cloud development environment. I think that is also very, very critical to be able for the OEM to enable the service platform. So I think the standardization, how this kind of environment can be created for OEM and also for the application and the service provider or the developer, third-party developer, will be very, very critical. So I think this is also need a lot of effort. And it's not only just the OTA. I think just like Alex mentioned, there's a lot of different kind of service. But I think about the creating this kind of service, you have to create a development environment to enable a lot of the more developer to be able freely to use that kind of development environment and the tool to make this kind of innovation for automotive.
Okay.
Well,
I want to add one more area.
Yeah.
The technology-wise, I think you're evolving. It will be becoming better. But talking about the infrastructure or even about business model, that's a whole new ecosystems. Traditional on the smart road, you only need a pole or some sign. But later on,
Yes.
you need to put all the smart poles or even on the roadside units. That's all electronic equipment. It's expensive. You need to maintain. So where is the money coming from? Or how to maintain is a very big issue. And so when you're talking about connectivity, we actually need to be very creative way to understand how to come up with a business model, how to making money. Even the regulations. Traditionally, when you add gas, they have some tax included with gas. In the future, there's no gas. It's coming from electricity. So how to charge is also a regulation or some policy issue. So local government also policy will influence the development or the progress of the connected car very critically. Just want to share this point.
Okay, yeah. I'm just going to, quick housekeeping. I understand we have people listening online. There is a little bit of a challenge in hearing all of your words because of the mask. So you may need to just project your voice a little bit more because to overcome, there's a lot of cutting of the words. So maybe you can just project your voice a little bit more into the speaker when you're speaking. So I think maybe our online community is not hearing everything you're saying. So if that's okay. So yes, I think about a lot about the connectivity, the infrastructure, but then the next thing I suppose is around data. There's going to be lots and lots of data as we have more and more connected cars. I think I read in an article how we're going to deal with the data tsunami in cars that's going to be growing as we have more and more connected vehicles. So, how are we going to deal with that? It's not just about processing the data. There's obviously things around what do you keep, what you don't keep. So storage, and then And then, yeah, just the masses of data, how do you process that data? And then what kind of compute operations are done on that data? How do you do the AI to get the right information? So there's a lot going on. So maybe each of you have different perspectives on this. How are we going to deal with the data tsunami that will happen when we have more and more connected vehicles? Who would like to start? Who feels really passionate?
I do. Given I work at NVIDIA, definitely passionate about that one. But yeah, like you said, there's a lot of data, and it doesn't have to be real world data either. Sometimes it's synthetic data. And with all that data, we have, that's why you see so many companies moving towards cloud-based solutions and, high performance computing to put all that together and analyze it and train models, create new AI models, whatnot. But that's why it's so important that you're able to scale up and down your solutions, right? Everywhere from your edge computing in the in-vehicle to, clouds and high performance computing centers so that they can process all of that data and come up with the right, or to train the best models possible so that you have this accurate model to prevent any, issues or better your driving experience, make it safer, all of that stuff together, and in-cockpit services as well. So there's so many different applications to this now. And when you're looking at, say, in terms of processing all that data, that's why actually all of us work together on this.
And also from ARM's point of view, actually we see the same trend because we've been asked for higher performance data processing CPU, GPU, and also the ISP. So, but not only just the process architecture to deal with different type of the data, but at the same time, all these kind of processor need to be centralized. So, which means that different type of the process architecture need to be running on the software, on the same software platform. So, which means that they're under the same software architecture. And this is also the trend, and especially this kind of trend is involving in the edge side, in the vehicle side, because the real-time data need to be processed in the edge side, in the vehicle, not in the cloud. Okay, so this is one thing that I think we have seen that the evolution or the trend to demand more processing performance, but at the same time, OEM also have to concern this kind of a power consumption and also the heating and the thermal issue when we introduce the high performance process architecture. This is, I think, ARM is really contribute this kind of area. But there's another side, because the data generated from the vehicle, in the future, you have to provide this kind of access of this kind of vehicle data to different type of the application and the service, which might not necessarily coming from the OEM itself, but also coming from the third party. So how are you going to define a uniform or the kind of a standard interface and also provide a secured mechanism to access this important data generated from the vehicle is also very, very critical, which I think this is also ARM is trying to work with the industrial partner to build up this kind of a standardization and also trying to see if we can also realize this kind of standardization in the software architecture.
Yeah, that's very well spoken, Simon. So from Macronix memory point of view, I think we're working also with ARM and NVIDIA, a particular solution. I think this data tsunami is definitely a big issue. So from memory point of view, what we can do is actually we generate a model that, because for example, I take a use case, for example, NVIDIA do the graphics processing and AI recognize. So there's a camera that capture, on the road the images, which is high resolution, and pass that data to the main processor. If this is not being, well managed, then this big amount of data coming into the ARM's big processor then has a very big burden, right? So what we do is we call that the compute in memory. there's a lot of AI computing, for example, multiply and addition, that kind of things. Memory can actually help to process all that kind of things and pass that abstract or computed data into the main processor. So much more simplify the processing algorithms. Okay, so I think in the same time you talk about power consumption, and you talk about the computing power and everything else, that can all can be saved in this manner. So I think computing memory will help in this kind of aspect for this data tsunami issue. Yeah, thank you.
Okay, I mean, that's good. Alex?
I'm not expert on this one, but data, two type of data. One is more of the calculation or computate. That I think will become massive because video processing or streaming process. The other data is more like a valuable data. And people talk about garbage in, garbage out. So a lot of data might need to be screened out real-timely, not just go through the connection pipe and overload the connections. So to have very good AI training or real-time screening or distributed processing. So when we're talking about connected vehicle, I think there's a term you will always heard is the edge computing. The local computer will do all the intelligence unless there's a need go to a server. So this kind of distributed computation will really dramatically reduce the amount of data. Thank you.
Okay. Yeah, so I think we've got some perspective there on sort of dealing with the data. When you have the data and the connectivity, the next thing people think about is security. And I think you did touch on there was one of the answers touched on it earlier. But so yeah, there's potential security breaches and cyber attacks. For a connected vehicle, that can be quite dangerous. What are the cybersecurity challenges and solutions for connected vehicles? I guess the scenarios, can be all kinds of scenarios, but we probably aren't there yet. But there have been hacks. I've written about those where EVs have been hacked, connected EVs have been hacked. So in a way, we need to just understand those and see what things maybe as companies in that ecosystem are doing things about to enable that security, I guess. So yeah, I think maybe Jeff, because you've obviously got some of the heart of that with ARM. So let's start talking about that a little bit. Security.
Well, cybersecurity is definitely going to be an ongoing challenge, right? Hacking from say 20 years ago versus now versus probably 20 years from now is entirely different. I feel that it's an ongoing process, but that's also why we have the need for software and hardware-based cybersecurity measures. And that's why you hear of all these protocols like zero trust and whatnot, so that we need to make sure everything's hopefully unhackable, right? Hopefully. But I think it's one of those things that that's also why we have products like the DPU or whatnot to specifically target processing the cybersecurity algorithms and making sure that side doesn't eat into the loading on your actual processor, but be it on the server side or even in vehicle, on edge side. I think this is a constant challenge for pretty much every company, because oftentimes you're not sure what you're dealing with if you haven't dealt with it yet. So all you can do is anticipate what might happen and try to plug all the holes there. But if something happens that you haven't seen before, it's going to be something that you're going to have to quickly be able to solve.
I think I can add some comment. I think last year ARM released the confidential compute technology. So that is also kind of addressing this kind of a security issue. So, but what ARM is now trying to do is not only, it's only just for the the processor, the semiconductor point of view, to provide the prevention or the isolation when this kind of attacks happen in the processor from the instruction level. But we see this kind of threat or the attack from especially the connected vehicle, is not only just the processor or the instruction set. It's from the domain, because for the infotainment or from the service channel. So this is like a domain's threat. It's beyond the computation platform and also the hardware and the software. So I think a lot of a standard already define a standard kind of a criteria to provide the security level and also the protection for the security threat. But I think from the domain's application point of view, there's a lack of the standardization for example, like ADAS, vision ADAS. There's a different kind of threat versus for example, infotainment. There are total different type of the threat that we need to take care from the applications point of view. I think that is also a critical thing that we need to address.
Yeah, again, I would also want to address from the memory perspective. So conventionally, when we look at the, for example, hardware architecture, usually the memory is just a very neutral storage media, right? So when the MCU or CPU that store the data in the memory and access from it, actually it gives opportunity for the hackers to probe, very crucial data out. So what we do in the Macronix actually to enhance the cybersecurity is that we add encryption mechanism inside the memory, okay? And that's actually some project we do with NVIDIA at this moment. And so the data exchange between the memory and the MCU or CPU is also encrypted, and encrypted with unpredictable key. We call that the POF key. Okay, so that's generated from the intrinsic characteristic of the semiconductor itself, so which cannot be predicted. That's like a fingerprint of human, which is not predictable. Okay, so I think this kind of mechanism, I think, should exist in all the cybersecurity area to enhance the security mechanism of all the data exchanges.
I suppose we'll come to Alex in a minute, but I suppose it's a non-issue. But when you're doing that validation and authentication, I suppose, is there a delay or a latency which could be critical in a connected vehicle environment, or is it irrelevant? I'm just curious.
I don't know, Jeff. From our point of view, we discussed, and of course there's latency, so that should be acceptable latency for security, right?
Yeah, definitely. This is, latency, especially when it comes to, say, a connected vehicle, is critical. But at the same time, that's why we keep talking about edge computing. Alex also mentioned that earlier, saying you'll keep hearing edge computing, right? It's largely because the processing would be put in vehicle, right? It's really crucial. You can't use, at least as of today, you can't rely solely on connectivity. What if you lose connection or whatever reason, right? So that's why the hardware encryption and the software encryption within the edge device or edge vehicle is vital there as well. So to minimize any latency.
Yeah, I guess that, but I just wanted to make sure we address that. Alex, what are your views on security?
Security always there. What I can say is a trust on the technology, and it will evolve it. There's no way you can say no problem or hacking will gone. So technology and work together. That's my comment.
Did you say technology? Trust in the technology, is that what you were saying?
I trust the technology will be evolving and able to catch up the threat.
And as an association that is seeing a lot of what's going on right now, have you seen anything that worried you in the last 12 months about security?
Yes, but but it depends on scale. Okay, if you are big scale, the security problem become bigger. If I'm small, then I fix it.
That's my job to ask these questions. Yeah, I'm not going to ask you to explain what worried you if you don't want to say. So I guess I guess we'll move on. Coming to like we're here for the IOV forum in Taipei, in Taiwan. So what are the key opportunities for Taiwanese companies in this connected vehicles business? And it's not just about opportunities in Taiwan, because obviously Taiwan plays in the global ecosystem, and most of you play in global sort of customer supply chains. So I guess just wanted to understand sort of where do you fit from Taiwan, and then also what are the opportunities in connected vehicles for you sitting there in Taiwan?
Yes, car industry is transforming to digitalize. Traditionally, engine, mechanicals, or gasoline, we can contribute only a small part. But as a transformation to digital, everything will be different. So Taiwan, the strength of Taiwan ICT and the semiconductor industry, or even the software companies, do see a lot of opportunities. I can say we do see some area is strong growing, and Taiwan has the possibility to win the market, like government and the industry funding together about the e-bus, the transportation bus, or even the 2-wheel, 3 wheels, vertical niche application-oriented motorcycles. And in addition to that, I think the road, traditionally the road will become a smart road. You need a lot of edge computing, sensors, or even the communications to help the safety of the road. So we do see a big opportunity on roads, smart road, roadside units. So what I want to emphasize, the car or auto industry is a major transforming and the innovation needed. So I do see it based on the Taiwan ICT strengths, and it become more important. And we do see a lot of opportunities here. Thank you.
Okay. In my experience, what I've seen in Taiwan is a lot of AI startups, which can help in some of those, for example, managing and processing that data, I guess. Yes. So it's quite interesting to see. Would anybody else like to offer some perspectives?
Yes. So I would like to share a scenario that that really occurs a couple of years ago when before the pandemic, I visited one of the major tier 1 in Europe. And they're closing down that particular facility I'm visiting. They're doing the analog cluster in the particular facility. I think in that facility they would have about 4,000 people over there in Europe, and they're transferring that function into Asia. Okay, because the cluster is transforming into digital cluster. So the original analog cluster expertise in Europe is no longer useful for them. So they transferred that into Asia. I think that's one of the key opportunity for us here in Taiwan. We're very good at making PCs, making smartphones, making this hardware and software solutions. So like Alex just mentioned, those infrastructure, so traffic lights, connectivity in terms of Bluetooth and all the hardware software integrations. That's what we are very capable of in Taiwan. So I think that's a very good opportunity for us here. Yeah.
Okay. Well, I think that's kind of concurs with what I hear. So interesting.
And also
Does anybody else want to say anything?
I can put some comment on that. We have a lot of partners in Taiwan. So I think with the connected vehicle, this will enable the cloud native paradigms. And this will also enable the software-defined vehicle. And which means that the hardware and also the software architecture and also the service will be dramatically changed, which means also create the opportunity for the leading positions company in Taiwan. For example, the semiconductor company. If you look at the TSMC and also the IC design company, they are more and more focused on the automotive application. There are more opportunity for them to, even they don't have the historical ability, but because they own this kind of advanced process node and also the advanced technology, I think that will create the demand from the traditional OEM to kind of accept the Taiwanese traditional ICT company, especially in the semiconductor. Another example is the panel. I think maybe everyone know that the panel gonna be more because you gotta have a lot of data in the vehicle, so you got to show that. So there will be a more display, different type of display technology will be in the vehicle. And the Taiwan's display industry is also in a leading position, especially in the automotive industry. So I think there's a lot of new opportunity, even for the traditional Taiwan's ICT company.
Yeah, I totally agree with that. But I think when you move slightly away from all we know right now, I'm actually, like personally, this is probably not NVIDIA, but personally, I'm very excited about just potential innovation, right? Like even when the cell phone came out, like the quote-unquote smartphone came out, we didn't think that much in terms of what you could do with it. You could play MP3s, you could maybe go to a couple websites. Now our lives are connected to the phone, right? I work off my phone these days, right? So I'm actually very interested in seeing with 5G connectivity, with all these new developments, with the increased processing power, increased memory, and increased everything within a car or within a vehicle, what new things that we haven't thought of? Like even at NVIDIA ourselves, right? We started with looking at, say, and for an autonomous car, okay, how do you drive the thing? What do you need? What type of networks do you need? What type of models do you need to develop? And then we slowly increased that into the user experience side, going the in-cockpit stuff. And that was a later development that, at least personally, I did not think of at first. So I'm actually interested in seeing what are the new developments that no one's thought of, right? How will our lives change with that?
Interesting. I'm going to move to a final sort of future look question, but let's close on things like future trends and innovation in connected vehicle design, and what do you see coming to fruition over the next 12 to 24 months? Let me preface it a little bit. This morning in the UK, there's a headline that says, main headline in the Times newspaper, there's going to be a change in the highway code. Highway code is what we all have to learn to be able to drive on the road and pass a driving test. It says you'll now, with self-driving cars, we're putting a rule in that says you'll be able to watch TV at the wheel, but not use mobile phones. I'm thinking that kind of scenario, we could only imagine, apologies for the word, but anybody who's watched Jetsons in the 70s and 80s, where you can just sort of do all these things. I want you to think out of the box. What are the things that you see coming in the future, but also what are the things that are real in the next 12 to 24 months, like watching TV in a self-driving car? So I put you on the spot. Who wants to be futurist? I know there's a few of you probably who have CEOs who are very futurist in their thinking. Should we start with maybe Jeff or Simon?
Sure, I'll tackle that. Well, futuristically speaking, right, we keep, when we think of regardless if it's watching TV while you're driving or something like that, I think one of the key things that you just mentioned was that the UK just passed this policy, right, to the highway code. I think that's one thing that's required for any development in this area. Otherwise, no one can actually test anything on road. But that's one of the steps to get to being able to go the Jetsons route, when you can just kind of, that's in terms of future development or like futuristic thinking, that kind of drives, okay, this is going to be a shameless plug for NVIDIA, but like that's why we have Drive Chauffeur, right, and Drive Concierge. The idea is, even if, especially in a metropolitan area like Taipei, if I can just get out of my car, say, go park yourself, and use my phone to get it to come back, just that alone would be amazing, right? Some of these things, regardless of if you're in the car or not, if my car could just do that, I would be so happy, right? I don't need to worry about
that.
Oh,
you
no,
do
no.
that already with home automation.
Yes, but I mean, like, I can just get out of my car anywhere and just say, go park yourself. And then whenever I need you, use my phone, let it come back in a legal manner, right? In tests, sure, it works. But you need it to be able to actually utilize that as a consumer, not as an employee of NVIDIA, right? So some of these futuristic things, that it's not full-fledged, get in the car, go to sleep, but it gets you closer. And just these steps getting there would be really amazing, right? And
okay. And maybe I'll come, after you've all done your future bit, I'll come to the 12-month vision last. So let's go now to Simon.
So I think from the coming, if I have the dream requirement for the next 12 months to 24 months, first, I think for the vehicle, definitely the safety, right? So I will expect there will be a dramatic improvement on the safety function, because that is the foundation. Then currently, like the L2 Plus or even the not going to the L3. So I would expect there's a lot of a vehicle will be available in the next 1 or 2 years from the technology point of view, will be able to do these L3s, which means that you don't need to really touch the wheel, and you have a lot of freedom to do that. So after you are the vehicle satisfied with the safety, definitely we want to, like the convenience, right? So just like Alex mentioned, I don't want to spend my time and the critical things to park in the car, and also trying to. So the convenience, I think the feature will be also one of the area that we expect, because the technology is already there. So after the vehicle satisfied with the safety, convenience, then the fun, right? The enjoyment. So the audio and also the video, I will expect probably in the next 1 or 2 years, the car OEM will be put more entertainment, the human machine interface will be more enjoyable. And we will create, for example, I have a conference call in the vehicle, and I need to have like I don't want to disturb with the other passenger. So a lot of this kind of advanced technology will be available in the vehicle. So I think this is from the safety, from the convenience, from the enjoyment. I think that there will be a kind of an expectation from the consumer point of view. But I think all these kind of things, it will be more important. I would like to see in the next probably 12 to 24 months is from the government's regulation to really make this kind of a vehicles constraint or restriction in the road, on the road, can be really open. We know that in Japan, in Germany, it's already opened up, but I would like to see if there's more, for example, like Taiwan, that we can have like a robot taxi really on the running and have a commercial test try like US or like in China, like we can have that kind of things released on this kind of regulation so that we can have a more innovation in the vehicle industry. Thank you.
Yeah, I think go along with Simon's comments. He talked about Germany and Japan legislation has been passed for level 3 cars on the road. I think that would lead the way for autonomous driving legislation, which is crucial, as Jeff mentioned, for I think all the components of from technology point of view, pretty much all available now. What we're missing now is legislation to let technology to play the role in this place. Yeah.
It looks like
I like to add one more different angle of use. Actually, Simon say is very good, and it's more like coming out from the user expectation. But if you go down to the customers, what transportation of the car is from A point to B points. So actually, what I want, or really it's been happening and doing is the on-demand transportation. More technical term is MaaS, as mobility as a service. So imagine that if I want to go to Paris, okay, and I have 5 days, and what time to what time is the period, then all the transportation is multimode, is arranged, okay? Any delay will be automatically compensated. Then that's really what customer want. It's more like you want the water, you open the tap, okay? You touch the tap. So if I want to go to somewhere, and the car is arranged, and all the different modes or connections has been seamlessly connected. So it's nothing to do with really autonomous drive. It's kind of fleet management and share. I don't need to own a car in order to repair it, okay? So MaaS, it will really change the life. You don't need to own a car, and the public transportation will be shared, and will be more efficient, and become more green and less traffic jams. So this is a different view from really customer need. Thank you.
I think that's quite important. I think you've all summarized it quite well in terms of having the right. It's not about the technology; it's about the rules and regulations and the governance, but also having the services for convenience. We've actually run out of time, so I'm going to thank you all for the participation. Thank you to the audience for listening, and we hand it back over to Susan.
Yes, thank you. Ladies and gentlemen, let's put your hands once again for Nitin, Gabriel, Simon, Jeff, and Alex.
Thank you.
Actually, we have another roundtable on Friday at the same time here. So hopefully we'll see you here again. Bye-bye. Thank you. All our panel speakers, please have a photo with Nitin on the screen.